In this lesson, we are going to focus on the scientific method and how it pertains to designing and running an experiment. This is something we will do almost every chapter, every unit, so it's going to be an important part of our class. In class, we talked about the scientific method and how it is applied to sciences. This method is used in all sciences, not just physics. It's a process that scientists go through when running an experiment, when looking at a problem, and how they actually go about solving the problem, collecting data, and then showing their results. Okay, and we talked about that this method, these steps that we're going to talk about, are not directly followed maybe in this order, but it's kind of just a way, a guide at which experiments and questions are ran. So, kind of just reviewing the steps, the first thing was when you observe a phenomenon or something you see in your everyday life and maybe you have a question about it, was first to formulate that question. Why does this happen? What's affecting a certain situation? Okay, you're formulating that question. That question really drives your experiment. Then, once you have your question, the next step was then to define the system. So what are we studying? What is the object of interest? Maybe it's one thing, maybe it's multiple objects. Okay, that's what the system is defined as. The next step, and this is really the important part, and this, from your question, this forming the hypothesis really guides your experiment. So your hypothesis is your explanation for why this is occurring. Okay, this does not mean it's correct. Does not mean that you are all of a sudden you know what's going on, right? It's kind of your guess as to why, how you can explain what is happening. Okay, so it's your explanation to the observed phenomenon. Once you have your hypothesis, the next thing is then to test it. And to test it, this is the focus that we're going to talk about today. When we test a hypothesis, when we test our question or our purpose, okay, we run what's called a controlled experiment. Controlled experiment is where we take some of the variables within our system and we test them out to see, okay, is our hypothesis true or do I need to fix my hypothesis? Okay, so today's lesson we're going to focus on that controlled experiment. And once we run that experiment, then we're obviously going to get some results. Then we interpret those results, we look at them, are we correct, are we wrong? And then depending on those results, we either reformulate our hypothesis and go through another experiment, or we now have results that show our hypothesis is true, and now we can formulate those results and then hopefully develop what we call the model. Okay, that's an explanation, or maybe whether it's graphical, mathematical, or some physical representation of what's going on in our phenomenon. So the purpose of this lesson is to focus on the controlled experiment portion of the scientific method. This is the one thing that we are mainly going to do in this class is develop and run experiments to test some of the things that we will be studying. So like we said, the first thing in the scientific method, and really it's the first thing in the controlled experiment, is to first develop your question or your purpose of your investigation or experiment. A lot of the times the purpose or the question may already be known because obviously we're not reinventing the wheel. So some of these things we're going to know already. But we're going to define the purpose and the purpose of the lab and what we are studying and all that. And really that's going to help us to guide our experiment. It's going to give us some of the things we may need to look for. Okay? That purpose or that question is going to also help us to formulate our hypothesis. So we're going to develop some variables and we're going to see, okay, do these variables affect another? And then what we're going to do is run our experiment, collect data, and then we're going to compare our results to what the question or the purpose of our experiment was. So throughout this, we're going to use an example. Okay, we're going to use an example of experiment that was ran a long time ago. It's a very famous experiment. Okay, it was run by a guy by the name of Galileo. I'm sure a lot of you have probably heard of him. Okay, in his experiment, one of the questions he had was when looking at two things, two objects, let's say a small block and a large block. And if I were to take these two different sized blocks, probably something that maybe the larger block weighed a little bit more, and I dropped them from some height. And Galileo asked himself, if I drop these two objects, which one falls faster? Simple question. Which one falls faster? Now a lot of you guys would think, and a lot of people back in the day thought, okay, the larger one is going to obviously fall faster because it's heavier or more massive, right? But with this experiment, just looking at two objects and dropping them, all right, that's a question. We're developing a question. We're developing a purpose to our investigation. Do heavier objects fall faster than lighter ones? So that's really our question. We formulate our question. That's going to guide our hypothesis, and then we can actually run and find some results. The next step of the control experiment is once we come up with our question, the next thing we want to do is define our system. Okay, and once we define our system, then we can gather up a list of variables. So going with the experiment we're talking about with Galileo, right, we have two different sized objects we're going to drop from some height and see which one falls faster. So if we think of our system, what are the object or objects we're studying? Well, the object that we are studying are these masses, these blocks, whatever they may be. Okay, maybe a penny, maybe a golf ball, something. Okay, these different objects are going to be our system. And obviously if they are falling, another object that we can include into our analysis may be the Earth. Okay, so maybe we are looking at those objects and the Earth. And this line right here represents here the Earth. Okay, so we define our system. Now the next thing to do in a good controlled experiment is to find what are the variables that could affect how these things fall. So in any experiment that we're going to do, we're going to derive a list of variables. Now with this list of variables, you are not wrong. If you can think of a variable that could affect how this thing falls, we need to write it down. We need to include it. Okay? Then once we get that list of variables, then we will go and think, okay, which ones can I actually test? Which ones can I control? All right? And then which ones would be affected? All right? And that's going to go through with our variables. So quickly, if we say, okay, let's think of this experiment that Galileo run. What are some variables that could affect how these blocks fall? Okay, well, let me just think of a few examples. So the first and most obvious might be the mass or the weight. Now those two terms are different, but for now I'll just say they're the same. The mass of that block. Would a heavier thing or a more massive object fall faster than a lighter one? Okay, then another one, maybe the size. Okay. We all know that we could have different sized objects like a golf ball, baseball, basketball. Some of those things may travel a little bit farther. Obviously, golfers hit a golf ball compared to a basketball. Does the size of that object make a difference? Okay, does maybe the height? How high we are dropping those objects. Are we dropping it from a 100-story building? Are we dropping it from where I'm standing? Those might affect it. It might be tougher to see if we're dropping it from a shorter height compared to a higher one. Another thing, if we're dealing with Earth, and maybe by the time Galileo was around, this was not known, but gravity. Okay, is gravity going to affect the object? Can we control gravity? If we think we're outdoors, we're dropping in a real-life situation, maybe the wind affects it. Okay, and one of the variables that these are things that we can control, but what are we really trying to study? Well, we're trying to see which one falls faster speed. Okay. So maybe the speed is affected. Maybe we can change the speed. So what I've done here is I've created a list of variables. Now, with a controlled experiment, this is the very important part. We want to know which variables we can actually control. That's hence a controlled experiment. When I say control, what I mean is something that I can change. So when something is being controlled, that means I can change it. Okay? I can change it without affecting anything else, okay? Or I shouldn't say without affecting anything else, but I can change it and it may affect something else, okay? Kind of opposite what I said. All right, this variable, any variable that I can change is known as an independent variable, okay? It's an independent variable. It's one that you can change. And that's usually the ones that we're in any lab that we are going to affect. We are going to alter to see if it affects something else. This is known as the independent variable. Usually when you change another variable, these independent variables are not affected. Okay, so it's not affected. And then what we're going to also look at with these list of variables is if I change one of those variables, the independent variables, will it affect another one? So will another variable be affected? These variables are known as the dependent variables. Dependent, to depend, means that it relies on something else. So if I change one of the independent variables, will something else be affected? Okay? The one that is affected by the change is known as the dependent variable. So these are the list of variables, or from the list of variables we're going to come up, what is our independent, what is our dependent, and we're going to go from there. So if we look at our list of variables up on the top here, looking at mass, size, height, gravity, wind, speed, now we look at our list of variables and we're going to determine which one are independent variables, which one are dependent. All right? So, looking at the mass, ask yourself, is it something that I can change? And if I can change it, will it affect something else? Well, this is probably the more obvious thing. This is really the one variable that is guiding our question. So the mass is something that I can change, and if I change it, it might affect something else. So this variable here would be an independent variable. Okay? The size. All right, can I change the size? Yes, I can obviously change the size. Will this changing the size of the object affect how fast it's going to fall? That's also true. Okay, so the size is something that I can also change. So that's another independent variable. The height. Can I change the height, and will it affect how fast things fall? Well, yeah, I can go with different heights, and maybe, just maybe, they might affect it. So height is another independent variable. Again, I'm changing these things, and it may affect something else. Gravity. Can I change gravity? It may seem like a silly question. I cannot. So gravity is not an independent variable because I cannot change it. At our level, you can't. The wind. The wind. Is the wind something I can control, something I can change? Again, no, this is not. I can't control the wind. But it is something that I can make sure that I can eliminate. Right? You can eliminate the wind by doing this experiment on a calm day. All right? And now the speed. Can I change the speed? Now, you can, I guess, change the speed by taking it and dropping it compared to throwing it down to the ground. But by throwing it, you're affecting really the whole purpose of our experiment. We want to know when two things fall, so they're dropping freely. So the speed is something that I cannot directly change. I cannot directly affect. It's affected by some of these other variables we talked about, the mass, the size, and the height. So the speed is affected by something else. So the speed is my dependent variable. Now in this list, I have 3 independent variables, mass, size, height, and I have 1 dependent variable, the speed. So my experiment I can now guide by saying, okay, I want to test these 3 variables and see how they affect the speed. So now my experiment can be run because I know what my variables are. So the variables we have in this experiment, or this example we're using, are the mass of the objects, the size, and the height. Yeah, those are my 3 variables. All right, and my dependent variable was the speed. So what you always have to remember is the independent variables are ones that we are changing, the ones that we are testing. And the one that is affected is the dependent variable. Now notice here there's one thing. Okay, and this is a very important part of a controlled experiment. I have 3 independent variables. Okay, that means I have 3 things that I can test. Now, what I want to do with an independent variables, and this is a key thing, is that in any experiment you can only test 1 independent variable at a time. You cannot test more than 1, because let's say I want to test the mass, but yet I change the size. Okay, if the speed or if how fast those objects fall change, I have no idea if it's the mass or the size that's affecting it. So I can only test 1 independent variable at a time. In the other variables, I have to hold constant. I have to hold them the same. So if I change the mass of the object, I have to keep the size of the object the same, and I have to drop them from the same height. Same thing goes with the size and height. Whatever I'm changing, I have to hold the other independent variables constant. I don't have to hold a dependent variable constant because it depends on the other ones. But it's always a key point here that you have to make sure that you change only 1 independent variable at a time. Otherwise, your experiment will be affected. Okay, so now we're going to go into actually collecting data. So in any experiment that we're going to do, once we get all our variables, the next thing is collecting the data. Okay, so the first thing we're going to do is draw something called an apparatus. Okay, and an apparatus is simply a diagram of our lab setup that includes the variables we're testing and whatever materials we're using. All right, so it's just a drawing, just in case someone were to take our lab and want to reformulate it, that they could look at our drawing and say, okay, here's what they did through a nice picture. Okay, so if let's say I'm using our example of Galileo, let's say here's my picture. Here's the floor. Say I'm taking an object and I'm dropping it down, and I want to test its speed. Okay, so there's a diagram of materials using an object, whatever it may be. You can say it's a ball, and here's the ground. Okay, now let's label our variables. Well, one of the variables we had was the height. Okay, that's one variable. And usually I want to label that as an independent variable. So I can label that as IV. And then we can look at here, we can say the mass of the object and also the size. And if I know those quantities, it's something that I can write down. And then another thing I want to test is how fast, or the speed. So you can label this however you want. I'm just going to label it like this. Usually we relate that with time. So I'm going to write time there. Okay? So it's just an apparatus, a drawing of what we are actually doing. The next step in a controlled experiment with data collection is once we have our variables, once we have our apparatus, the next thing to do is to organize things in a neat and organized data table. Alright, so a data table is just where we're actually going to put our data, where we're going to put all the numbers that we are going to acquire from testing these variables. Alright, so with your data table, what first you need, you're going to have a whole bunch of independent variables. Like we've seen, we have 3 independent variables in this example we're using. So I'm going to need to create 3 separate data tables for each independent. Why? Because with each independent variable, I can only change one at a time. So as I test the mass, I have to keep the other 2 constant. And if I want to test the size, I got to keep the other 2 constant. So really what's happening when you have 3 independent variables and testing one at a time, you really have 3 separate experiments going on in one. Therefore, you need a data table for each one. Within your data table, you need to make sure you label your variables. So you need to show what is your independent variable, what is your dependent variable, and what are any constants that you're holding true. Okay? Those things need to be included in every data table. However you decide to organize it is on your own, whatever you want to do. Okay? The more organized, the easier it is to see your data and to see kind of results. Alright? With your data then, you must include 2 things, what's called raw data and generated values. Okay, the raw data, think of like raw meat, is stuff that's just pure data, right? We're not affecting it, we're not cooking the data at all in any way. Okay, we're just taking it, we're measuring it, nothing's calculated, we're just taking data and collecting it. Alright? That'd be like taking an object and measuring its mass by putting it on a scale, measuring the mass. Boom, I collected the mass. Okay? Then the generated values are like the cooked raw data. You are now taking your raw data, and if you need to perform any calculations, you're going to do that. Okay? So let's say I collect my raw data, I collect the mass. Let's say I collect it in kilograms, and I need to convert that to grams. Well, I measure it in kilograms, so to convert, that's going to require a calculation, a conversion. So I'm going to show that calculation on my data table. That conversion is going to be known as a generated value. Now, it's kind of a simple example of that. And then lastly, in our data table, the last thing that's really important is that we always record things in our base unit. Okay, think base units of length, time, mass, and all the other ones we talked about. Okay, you always need to record length in meters, and mass in kilograms, and time in seconds. Okay, those 3 things are those things that must always be recorded correctly unless you're told otherwise. So here's an example of a data table. Let's say that I am testing the mass. My 3 variables are mass, size, and height. And I want to test the speed. Which one's falling faster? Okay, so let's say okay, I want to set up my data table. Well, I need to include all my independent variables, my constants, my dependent variables. Okay, so one of the things I'm testing, my main independent variable first, is the mass. Okay, and let's say I want to measure the mass in kilograms. Kilograms the base unit, so I'm going to label that. Okay, I'm going to make columns here. So I'm going to test the mass, and I'm also going to include my constants, so my size, whatever that variable would be or that unit would be, and the height. Height again is a length, so I'm going to measure that in meters. Okay, and then speed. Maybe I can't measure speed directly, so let's say I'm going to measure time. Okay, so time, and that's labeled in seconds. So what I have here is I have my independent variable, my constants, and my dependent variable. And this is how I'm going to test it. So let's say, okay, I'm going to choose a mass of 5 kilograms, and I'm going to go up to 10 and to 15, whatever it may be, predetermined amounts, you're changing that. The size, let's say it's 10 centimeters. Okay, this value, 10 centimeters, if it's a constant, is going to be the same all the way through the experiment. Let's say I'm dropping it from a height of 50 meters, pretty high. Okay, again, that's constant, so I'm going to leave it the same throughout the whole thing. And then my time is the dependent variable, so this is going to be affected by the mass. So these values are going to affect this. So where you're going to see different values is with the mass and the time. Okay, but this is showing you how I can simply organize a data table, and it looks pretty neat. Now, once you go through all those steps, now we actually collect data, we get results. And the last thing that we're going to do is go through and try and develop a model of those results. We're going to see, what did we see with those variables? Did any variables affect the speed, or did any of the independent variables affect any of the dependent variables at all? So we're going to evaluate the data, and then once the data is evaluated, then we're going to develop a model. If there is a relationship, then we're going to see it in a model. Now, with the model, obviously this is the very last step. We need to make sure that our data is correct, that our results actually show something. Okay? So in this class, when we develop models, we're really going to develop them two ways. The first way is graphically. So we're going to take our data and actually develop a graph. And the graph is going to show us a relationship, and we're going to look at graphs and be able to determine what are the relationship between the variables given a graph. So the graph is going to be a model of that relationship. And then the next thing we're going to do is look mathematically. Okay? And these two are going to be tied in together. Mathematically, when I see a graph, okay, it's going to give me a relationship. And then from that graph, I'm going to formulate an equation. And that equation is a mathematical representation of the relationship. And then once I know that equation, then I can use that equation in a general sense. So let's say there was an equation for mass and time. Therefore, I can take that equation, I can plug in, let's say, any mass. I can plug in 100 kilograms, and then if I compute it, it's going to pop out the time, and it's going to tell me what time it's going to take to fall down. Okay, so that's a mathematical model of what's going on. So our models are going to represent our relationship. Okay, so this whole process that we talked about in this lesson is the scientific method and how we are actually going to use it in this class. Okay, we're going to go about actually performing an experiment that actually goes through these steps, listing the variables, all that, independent, dependent, drawing an apparatus, collecting data, developing a model graphically and mathematically, and then that's going to guide our process throughout every chapter, throughout every unit, is looking at those models and how they actually pertain to everyday life.